Okay, so today's topic is finding the equation of tangent lines and vertical lines. Or sorry, tangent lines and normal lines. So the derivative, the whole point of the derivative, why we like the derivative so much is because it finds the rate of change for us. And if you can tell me how something is changing, then I can make a prediction about what's going to happen going forward. So we can use equations to model situations, and then we can use the derivative to figure out how those situations are changing, and then we can predict what's going to happen. We're not ready for that. That's what we'll do in calc, but right now we're going to try to come up with an equation that shows us how the graph is changing at a specific spot. So let's review. If I want to figure out the equation of a line, I need two things. I need a point. Points come to us in the form of x and y. And I need a slope. Now, before, when we did this in Algebra 1 and we did this in Algebra 2 and we did this at the beginning of the year this year, we had 2 points. So we could do y minus y over x minus x, and we could get the slope that way. When you're trying to figure out the rate of change at a single point, we don't have that second point, which means we can't do y minus y and x minus x. So the slope in this case turns out to be the derivative. So the slope and the derivative, the slope of the tangent line and the derivative are going to be the same thing. For the derivative at that point. Now you can write your equation in any form. So if you remember, we have slope-intercept form, we have point-slope form, we have standard form. The best form we've found, at least for calc, is to write it in what's called Taylor form. So Taylor form looks the same as point-slope form, except we move the y1 to the other side. The reason we like this form so much is because we could type it into our calculator. Our calculator always needs y equals, and this is set up to be y equals. So let's see if you could do this one on your own. Here's Taylor form. Your point is at -4, -3. Your slope is -2. Plug and chug. What would your equation look like given those two pieces of information? Check in with a friend. See what your friend thinks. I'll give you a hint. The y should stay as y, and the x should stay as x. Everything else should change. Let's go. Give it a try. Come on, friends. We're just plugging and chugging. All right, so my equation is Taylor form is y equals y1. So our y is -3. Plus the slope. Now, I always like to look ahead to see if my slope is positive or negative. In this case, it's negative, so I'm going to use a subtract 2. Maybe you wrote plus negative. That's fine. -2 times the quantity, x subtract x1. My x1 is -4, so that's going to turn it into a positive. There's our equation through that point with that slope. What do you think? Now, if you wanted to distribute, you could distribute, get this into y equals mx plus b if you like those other forms. We're going to learn to like this form, or my prediction is you're going to eventually learn to like this form. Okay, so now we've got all the info. We can start to apply it. So we've got this function. I've graphed it over here. We want to find the equation of the line tangent to f at x equals -1. So again, if I want to find the equation of a line, I only need two things, a point and the slope. So they gave us a little bit of a hint. What did they tell us? What's the only hint they gave us? X is -1. So I can start off, I need a point and I need the slope. Those are the two things I need to be able to make an equation. Well, they told us that our x number is -1. So I'm going to take, and I know that my x value is going to be -1. Now I need to figure out the y value. If you know an x value, how would you find a y value? You could graph it. That would be the quickest way, but let's pretend like the graph wasn't there. What's the other option? Plug it into this, right? If I plug in x, I get out y's. Yes? Now, like Zach said, we know it should be at a height of 0. Let's see if that is actually what it turns out to be. So if I plug negative 1 into this, it would be negative 1 to the 4th. Negative 1 to the 4th would be 1. Negative 1 into a cubed would be negative 1, but another negative would make it a positive 1. Negative 1 squared would be positive times a negative, so 1 plus 1 take away 2. Yep, that ends up being 0. Now we get to apply some of the calculus, and this is the connection that the slope and the tangent, the slope and the derivative are the same thing. So if I want to figure out this slope, I really need to figure out the derivative at that x value. Well, before I can figure out the derivative at that x value, I've got to figure out the derivative overall. So what type of rule is this? I would always ask myself that question, what type of rule? This is just a difference rule, looks like, which means I derive each piece. Each piece is a power rule. So that's pretty straightforward. That was the rule we learned first. So multiply and then subtract 1. Multiply and subtract 1. Multiply and subtract 1. So there's the equation for my derivative. But I want the slope, and I want the slope at specifically negative 1. So I'm going to take negative 1 and I'm going to substitute it in for all of my x's. Now we're going to start to clean that up. So a negative 1 cubed would still be negative, times 4 would be negative 4. Negative 1 squared would be positive, times negative 3. Negative 4 times negative 1 would be positive 4. And looks like the 4's are going to cancel, and I get a negative 3. So we found all the info that we need. So I just plugged and chugged to figure out what that slope was. Now I have a point. Now I have the slope. We're going to do exactly what we did in example 0. We're going to apply this information to Taylor form. So that would be y equals. You don't have to write the 0 here. We tend to do that in calc just to help us find out when we're plugging into a point, but you don't have to if you don't want to. Minus 3 times x plus 1. Okay, here's the moment. Ready to be dazzled? What point did we go through? Our point was at negative 1, 0. You guys know what a tangent line is? Have you guys studied that in physics yet? A little bit, maybe? I know we've talked in this class really quick about it, but yeah, so maybe from engineering. So what I've done is I've got one point here. Now remember, we normally do when we graph a line, we usually start on the y-axis, and then we do rise and run from there. But you can start by any point and then do rise and run. So I'm going to start at the point that we have, negative 1, 0, and then my slope is negative 3, which means I'm going to rise negative 3. I'm going to run 1. And then the reverse of that would be to rise positive 3 and go left 1. And now I'm going to connect the dots. Bum, 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 bum. Huh? How cool is that? That's the tangent line. Huh? Huh? You guys don't look as excited as I am. All right, you try it on your own. You're up. So I need two things. I need the point and I need the slope. Find those two things. You've got enough information to figure those out. Doing a little bit of calculus and algebra, of course. Actually, do we do any algebra? I don't think we do any algebra. We do some arithmetic. Calculus and arithmetic. Whitlow got 2, 2. Does anybody else getting 2, 2? Yeah. Oh, I see some heads nodding. Looking good. That's a good sign. Who has a 2, 2? Get it? 2, 2. Get it? Get it? Pretty funny, right? Get it? Get it? Okay, so if I'm given the x number and I'm given an equation, how can I find the y number? Tell me. What could I do with this x number in the equation to find the y number? Plug it in and see what you get. What do you think? Did you get it when I said 2, 2? Did you get that? It's pretty funny. Surprised you guys aren't laughing harder. You're laughing on the inside? Sure. Yeah. Okay, the hint they gave me was that x was 2. Oh, I got to write this out always. 2 cubed is 8. Take away 4 times 2. Oh, man, I could have done that in my head. Plus 2. So 8 minus 8 is 0. Plus 2 is 2. Now I need the slope. The slope turns out to be the derivative at that spot. I can't figure out the derivative at that spot until I figure out the derivative. This is a simple sum difference rule with the power rule. You guys get 3x squared minus 4x? Yeah. We're on board there? Now that's the derivative. That's the slope of all the points. So that's the function of all the slopes of every single point of our function f. I don't want the slopes everywhere. I want specifically the rate of change at 2. I want to see how the graph is moving at 2. So I'm going to plug in 2 for x. That means I've got to plug in 2 for x everywhere. Two squared is 4, times 3 is 12. 4 times 2 is 8. 12 take away 8 is 4. I got the slope to be 4. Do you concur? Yep. Thank you, Mason. Thank you. Now, if you get... What's that? It's been a long time, hasn't it? I always wanted to do that at graduation or something to see how many people would remember to do 2 snaps and a clap or something like that. Congratulations, class of 2022. Do you concur? Everybody does it? All right. So now I've got a point. I've got the slope. I can plug it into Taylor form. Y equals y plus the slope times x minus x. Box it in, put it up on my fridge. What do you think? Are you ready to be dazzled? The point 2, 2 right here. My slope is up 4, 1, 2, 3, 4 over 1. Down 4, 1, 2, 3, 4 over 1. Bump, 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 bump. That's a tangent line. The tangent line is the line that hits the curve at exactly that one spot. And it's exactly how fast that graph is changing. So as you can look, our graph is going up, and then it increases, then it decreases, and it starts to increase again. The slope of this line is exactly how fast that graph is changing at that spot. If this was the path of a baseball, which it really couldn't be a baseball because it goes, but anyway, this was a crazy baseball. If the ball hit you in the face at 2 seconds after it was thrown, that's how hard it would be thrown, would be the slope of this line. Kind of violent. Find the equation of the line tangent to f of x equals blah, blah, blah. All right, so now we got to ask ourselves again, what type of rule are we going to apply? What type of rule is this? So overall, I've got, what do you think it is? Actually, what do you think? What rule do you think this is? Chain. Why is it a chain? Because everything's underneath something else. You've got 5 seconds with a friend. Do your rewrite. What would be the rewrite of square root of 5x plus 5? Just a rewrite. 4, 3, 2, 1. Hey, no calculators. 0. My rewrite, I'm lazy in my old age. I just go up here and I rewrite this as to the 1/2. Okay, I need a point. They told me what x was. You and your friend have 10 seconds to figure out what y is. 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Okay, 5 times 4 is 20, plus 5 is 25. Square root of 25 is 5. Now we need the slope. The slope will be the derivative at that specific x value. Okay, so you guys said this was a chain rule. So what magic word do we always say when we're doing a chain rule? Something. So who's our outside function? Something to the power of 1/2. What's the derivative of something to the power of 1/2? 1/2 something to the power of negative 1/2. Now we said something, so that means I need to keep going. You always need to keep going whenever you say something. So who is our something? 5x plus 5, and when you derive that, you get 5. Notice we didn't say something, so I don't have to keep going. The game is over once I've done all the layers. Now look, from here, guys, you can clean this up if you want to. But what are we going to do with the 4 now? I'm going to plug it in. So I don't want to clean this all up. You can, but why bother? Because you're going to plug in numbers anyway. So f prime of 4 would be 1/2 times, all right, 5 times 4 is 20, plus 5 would be 25 to the negative 1/2. Okay, I got the 1/2, that's easy. I got the 5, that's easy. Turn and talk with a friend without a calculator. What is 25 to the negative 1/2? And I'll give you a hint, do it in pieces. Think about the negative as a piece and the 1/2 as a piece. Turn and talk, go. Talk it through with your amigo or amiga. Peter, you can move back there if you want to just sit back there from now on. That seat's open. So close. Okay, let's talk it out. The two pieces are the negative and to the 1/2. Let's talk about the negative first. What does a negative exponent mean?
It's a fraction.
True, but let's get more general. Not necessarily. Not necessarily. It means flip. Why do I always want to say flip as opposed to on the bottom? Because if it's negative on the bottom, it's going to flip to the top, and it's not on the bottom. So a negative exponent doesn't mean it's on the bottom. It means it flips from wherever it is. Okay, so we'll apply the negative in a minute. What does to the 1/2 mean? Square root. So can we do 25 to the square, or 25 square rooted? What do we get? 5. Now, what do we want to do with that thing? Flip it. What's 5 flipped over? Which we wouldn't know since we're not supposed to have our calculator. So 5 flipped over. Okay, I'll believe you. Now look, somebody in my earlier class was doing this. They were doing 1/2 times 1/5 and got 1/10, and then they took 1/10 and times it by 5. That'll get you the right answer. But what's way quicker? The 1/5 and the times by 5 are going to undo each other. It's going to give you just 1, so we would end up with 1/2. You don't have to follow the order. As long as it's all multiply, you can multiply in any order that you want. So now I have my slope. So I can take my slope and my point and I can combine them. What do you think? Questions, thoughts, comments? All right. The last part is talking about the line normal to. What does normal mean? What's it? There you go. Well done. The normal line is the line that's perpendicular to the tangent line. Why they call that normal, I have no idea. So now we have to do a...
I know it from like 3D modeling stuff, so it's the normal, like the direction of like a model texture. So the normal of a face is kind of the perpendicular to it, and it's...
Sounds fishy to me.
As well as engineering.
Sounds fishy. Why would that be considered normal? Anyway, whatever. All right, so let's review perpendicular. If I have a slope, who is the perpendicular slope to, let's say, 5/4? Negative 4 over 5. So what two things did you do? Opposite and reciprocal. So to be perpendicular to the tangent, we need to do the opposite and the reciprocal to f prime. Now in this case, you'll notice that this problem is the same as the other one because all I really wanted to do was introduce what the normal is. You guys can do this on the back, but when you're finding the normal, you first have to find the regular tangent line slope and then reciprocal it. So since over here f prime of 4 is equal to 1/2, therefore what can we say about the normal slope? The normal slope would be negative 2. Now the point's still the same, the slope is different, so we don't have to do any more work. You would have to do more work on the back because I didn't have you figure out the slope.
That 3 dot symbol looks familiar.
That means therefore,
Okay.
from your geometry days.
I don't think we use that.
I would be, maybe. I'd be surprised. If you didn't do that in your congruence theorems for, but maybe, I don't know. All right. Yeah. Hey, take that. All right, gang. So homework is on the back. Rest of the time is yours. Go get them.